Now let's look into how much energy is required to raise the temperature of a substance, something known as the heat capacity. So if we have a certain amount of energy that's available to go into heating an object, that's going to depend on the mass of the object, and it's going to depend on how much we want to change the temperature, but it's also going to depend on this thing called the heat capacity. So this heat capacity is specific to every substance, and it's just a way to quantify how much energy is required to do that. And the units of heat capacity are joules per kilogram per degree Kelvin. So if we just look at the units of that, that makes the units work out so that we get joules from the outcome. Okay, so that that's just a way of quantifying how much energy is required to raise a certain amount of a substance, a given change in temperature. Now we also have to worry about the energy that's in the structure of a material when it's in different phases. So if you have ice, for example, ice needs to be melted before you can begin to heat it. And if you have water, it needs to be heated up to the boiling point before it can start to boil. But once it starts boiling, you have to change it from a liquid into a gas. And while you're doing that, all of the energy that you're putting into it goes into that phase change. And that's measured by something called the latent heat. And the latent heat is the amount of energy required to initiate that phase change. So we can write that down as the amount of energy that you need to put in is proportional to the mass of the object times the latent heat. And the latent heat is going to have units of joules per kilogram. And you notice that it's independent of temperature because the temperature of the object isn't changing while you add the heat in. It's all the heat energy is going into the phase change. And this is the same thing happens when you're cooling, right? If you're cooling water from a liquid phase to a solid phase, for example, that once you start to cool the water to ice, as it's freezing, the temperature is not going to change, and all of the heat loss is going to be because of that change in phase.